so his question was that the inverse Laplace has given an answer which is in terms of sine and cosine, but MathCAD mastering is expecting an answer which is in terms of a cosine with a phase shift. So how do you convert the sine and cosine form into the form with cosine only and a phase shift? So we look at the values that are on the cosine and the sine. We're going to use the magnitude of the cosine and put it into a complex number. So I'm making a phasor out of this, a complex number which has the value from the cosine, and then we're going to take the value from the sine and multiply it by negative j. And so this 4 from the sine will become a negative 4j. Now, once we have that phasor, we can take the argument of the phasor, which is going to be in radians. And of course, if you need it in degrees, you could convert that to degrees. But in this case, this is going to be the angle, the phase angle in radians. And then the magnitude of x is going to give you the amplitude of the final answer, right? And so you end up with the answer having this magnitude in front of the exponential part, and the phase angle I'm not sure why the angle got reversed here. We factored the minus 5t to the minus 5t out of these two expressions, right? And we're combining, because they have the same frequency, 8 radians per second t, then you can combine these two into a single cosine that has this amplitude with this phase angle.
So can we look at D? Because with that one has, we have to combine 2 cosine terms and 2 sine terms. So how do we go about part D?
So in part D, we get 2 frequencies. So we've got a 3t here and a 3t here. They both have the minus 5t, e to the minus 5t exponent. So we group these two, the first one and the last one here, and then we group the inner ones, which are 2t, with a different exponent, right? So we're grouping these two together and these two together. So we're building a phasor for the first and last one, and I'm doing that right here. On the for the first one. So we've got, let's see, this one is, which one, 18. So this is the middle group here, the 90 minus 92. So I'm taking the minus sign here, minus 92 and minus 18, but we're multiplying minus 18 by negative j. So this becomes minus 92 plus 18j. And we take the magnitude of that. These things are all over 13, or both over 13, and so we're combining those to form the magnitude that we need for the first one. The argument of that will be this value, which will get us in radians 2.95. The second one here, the second group, is coming from the magnitude of these two components, and this one is again 92 over 13 positive, and this one is 232 over 39, but we're multiplying it by negative j because of the sign. So we end up with this, and this gets us our magnitude, and the argument of that same then gets us the phase angle. So we can convert these things in this way, so that the 3t is picking up the argument here, and the angle, phase angle here, and its magnitude from here, and the 2t is picking up its magnitude from here and its phase angle from here. Right? Each one has its own exponent there that were factored out of those two terms and then put back in. So we've just separated it by frequency. Right? They have to have the same frequency in order to be combined. In MathCAD, we do limits with those symbolic, yeah, there you go, symbolic items. So pick the limit you want. And then you're going to make S go to the opposite thing that you're looking for. So for the final value, that would mean S is approaching 0.
0.
Okay?
So would this be infinity?
So then you're taking the f of s, and I believe you have to multiply the whole thing by s to get it to, so it's s times f of s. And then, yeah, you hit enter, and it says it's 0.
You just click the...
Okay. And then for the initial value, it'd be...
So for the initial value, you're going to let s go to infinity.
Infinity, okay.
I know, it's like upside down, right?
Yeah.
But
Oh, 0 again. Okay. I think I get it then.
alrighty.
Thank you.
So comments about the pair programming.
It's good.
I think it's good to see how other people solve versus how you solve.
Like different strategies.
Yeah.
And so every time, you've had a number of partners now, right? Because we change every time, so you're seeing different styles.
Exactly. Yeah. It's helpful.
Okay,
Yeah.
thank you.
I see people using different methods. Like some people, they follow the book, and then others, they have like their own ways. I have no idea how they figure that out. Like, there's multiple ways to solve a problem, I guess.